So, good morning to all. Am I audible?
Yes, sir.
Okay. So, yesterday we have started new unit from the first section, that is brake. So, we have seen functions of brakes. So, to slow down and stop the vehicle, to control the speed of the vehicle on turn, or to stop the moving element, that we have seen. So, this is the classification. Then there are two types, drum brake and disc brake. So generally our aim is to study the shoe brake. So this is only the information where brake is required and for its function I have shown. Now with respect to the syllabus, so this classification, first of all we have seen the function to retard and stop the motion of machine temporarily, and previously we have seen to stop the vehicle and to slow down the vehicle. So for that reason, what is what are the capacities or capability of the brake, and in the design it is required to understand various parameters. So brake is required to retard or to stop the motion of machine temporarily, that is when brakes are applied. It converts kinetic energy into the friction and dissipates the heat to the atmosphere. It acts as a safety device. So it is used to control and to stop the vehicle, and it is one of the safety device. Then this is the classification: shoe brake and band brake. Okay, this is the expanded classification that we have seen. Now we have seen this single block or shoe brake. Yesterday we have discussed it's a first case, various parameters. So P is force applied at the end of lever, then Rn normal force pressing the brake block on the wheel, then this R radius of the wheel, 2 theta, this one is the angle of contact surface. So this angle, suppose this one is the block, and this is the structure for the block, and here there is rotating wheel. So this angle is nothing but 2 theta. So this one is angle of contact surface of the block. Mu is coefficient of friction. Then Ft is tangential force or the frictional force acting at the contact surface of the block and the wheel. So this is the case. So Ft is equal to mu Rn. This one is the tangential braking force, braking torque, again force into the radius. So this mu Rn, this one is the tangential force and this one is the radius. Then this is the schematic of the single block brake. So this is the block. This one is drum or whatever disc. This one is the fulcrum where it is having facility to move in this way. Here it is fixed. So and to show the contact angle, this is again 2 theta. So this up to this, from this is in contact with the rotating drum. So This is the single block brake. Then case 1, that is when the line of action of the tangential force Ft passes through the fulcrum. So this is Ft, here it is Ft, and line passing through this fulcrum, they are coinciding through the fulcrum O of the lever and the brake wheel. Then, so what we need to take here, taking moment about the fulcrum O. So accordingly, we have seen here this Rn, this is the Rn into x, this distance, and Rn is acting in the upward direction with respect to the figure shown. So left hand side we have written Rn into this x and is equal to P into L, or you can write like this also. So for your understanding, so Rn into x minus P into L is equal to 0. So in sign convention, if you are going to consider anti-clockwise as positive and this way it is clockwise as a negative, then we can write like this. Again, just by rearranging Rn into x is equal to P into L. So that is written directly, or Rn is equal to this P into L upon x. Then we know the braking torque, that is Tb is equal to Ft into R. So what is Ft? Ft is mu Rn into R. So braking torque is equal to Tb is equal to mu Rn into x. So this is the braking torque when this Ft is passing through the fulcrum O of the lever. So in the examination, so like this they are going to ask, when line of action of tangential braking force Ft passes through the fulcrum O and the brake wheel, then the braking torque is equal to, or then braking torque, what is the value of braking torque. So they are going to give the options like this, mu Rn into R, or Rn into R, or mu into Rn. Like these options will be there. So what is correct option? This will be the option. So that's why along with the study, I'm just focusing on the MCQ. Then they have given the value of this Rn that we have seen here. Next, this one is the first case. In that we have seen clockwise rotation of brake wheel. This is rotating in the clockwise. Now what is change? Only change is with respect to the rotation of the disc. with respect to the rotation of the disc. Now, so here you can see that when brake wheel rotates in anti-clockwise as shown in this figure, then braking torque is equal to TB is equal to mu Rn and is equal to mu this Rn into R. So braking torque is not going to be changed whether vehicle or wheel is moving in clockwise or anti-clockwise direction. So whatever applied as application of this braking force, based on that there is requirement of the braking torque. Okay. Then case number 2. So to create the confusion, such direction of rotation will be added in the sentence or the in MCQ. सर गाडी पुढे जाताना लागणारा ब्रेकिंग टॉर्क आणि गाडी रिव्हर्स मध्ये येताना लागणारा ब्रेकिंग टॉर्क. So there is no change in the braking torque or whatever calculation we are going to do. Okay. Now second case. So when line of action of the tangential braking force Ft passes through a distance a below the fulcrum. So based on the design or whatever space available, this block may have different size, this disc may have different size, and that's why there is change. So when the line of action of the tangential braking force passes through distance a below the fulcrum and this much offset is provided, so this is line passing through the fulcrum. Now in this case, by considering the equilibrium condition, so we can write like this. So first I will write, you can just check, don't write anything. Rn into x plus Ft into A is equal to P into L. So this Rn into x, so that we have written here. Again, in the direction of rotation, this Ft, it is in this direction. So Ft into A. But with respect to this fulcrum, with respect to this fulcrum, so the direction of rotation, this is the fulcrum. For this Ft with respect to fulcrum, we are going to consider it as an anti-clockwise direction. So this is plus, and this one is minus P into L. So we can have for equilibrium taking moment about O is Rn into X, Ft into A is equal to P into L. So from this we are going to find out this Rn. So how to find Rn? Again you can have this PL divided by this FTA. So we can have the value of this FT. So what is the value of FT? We can write PL divided by this mu R N into A. Or before this also, just I will change. We can write like this RN into X plus this mu Rn into A is equal to P into Q. So this Rn, you can take common. So here X plus mu A into Rn is equal to P into L. And now we can write Rn is equal to P into L divided by this X plus mu A. X plus mu A. Now braking torque. So TB is equal to, no change in the formula, TB is equal to mu R N into R. This is for FT. So here we are going to put value for this mu, then value of Rn and into R. So we can get braking torque in case of line of action of tangential braking force passes through A below the fulcrum. Now, as an exam is based on the means MCQ type questions, so such relations, whatever displayed here, those are important. They are going to just rearrange the term and giving the option. So first we have seen this one is the TB. Whenever line of action of tangential braking force passes through the fulcrum. So this you should remember, or you should remember the figure, so that at 11th hour you can estimate and write there. This is for the second. Now in this case, so this is the clockwise that we have seen. Give me 1 minute. Just I was checking the content. Okay, so this is for clockwise rotation of brake wheel. Then again the same figure, but just anti-clockwise rotation of the brake. Now from the previous and this case, so this one is different. Here this disc is rotating in anti-clockwise direction. So for that, so previously what we have seen, that FT is passing through the full line of fulcrum. Now FT is passing at a distance A from the fulcrum. Then in this case, for the equilibrium, we are going to write the equation. So this R n into x, Rn into x, then minus P into L, we will equate it to the 0. Then minus, now this is EFT, through this distance it is going to rotate. So if you are going to consider, this is one example, and here EFT, then this is in clockwise direction. So minus EFT into A is equal to 0. So here we are going to write Rn into x is equal to these two terms. So that is PL plus FT into A. What is value of FT? That we are going to write. So Rn into x is equal to PL plus mu Rn into A. Now similar to previous case, we are going to take common out this Rn x. So this is Rn, here it is Rn. So directly when we are going to shift this term to the left side, here I will write mu A is equal to PL. So Rn is equal to this PL divided by. Now in the previous case, this Rn was हे जर क्लॉकवाइज रोटेट होत असेल तर त्या केस मध्ये इथे काय आहे, PL अपॉन x प्लस म्यू A हा डिफरन्स आहे, एवढं लक्षात ठेवा. सो दिस इज फॉर युअर information. So for equilibrium, this is written. Okay. Now directly braking torque. Braking torque is equal to Ft into R. So what is Ft? Mu Rn into R. So what is mu? What is this Rn? That is PL upon X minus mu V. So with respect to the second case, whenever that tangential force acting through the fulcrum, line of fulcrum. So to summarize, you can check this. Here, just I will take one more slide and then we can discuss regarding the, okay. So this Ft is equal to, हे लक्षात ठेवावं लागणार तुम्हाला, mu Rn, then braking torque is equal to Ft into R. Therefore, Tb is equal to mu Rn into R. This is equation. Now, in first case, value of this Tb is equal to, so we need to put value for this mu and here R. So what was the value for that Rn? That already we have seen. So Rn is equal to TL upon X. This is when this tangential force Ft passing through the fulcrum. असं थोडं समराइज करावं लागणार तुम्हाला. Okay. And it is rotating in clockwise or anti-clockwise. This is the answer. Now, in second case, this is when this one is tangential force, this one is the clockwise rotation, and such offset A was there. So in that case, this Tb is equal to again mu Rn into R. So what is value for this? Mu as it is, and value for this is PL upon X plus mu A into R. So again, if this rotation direction is changed, if it is anti-clockwise, then what is changed? Tb is equal to mu PL upon X minus mu A. तुम्हाला सगळ्यांना अशी समरी करावं लागणार, one page, and then you should remember, try to remember. So per chapter there should be one page in your own language, in your own write-up. So two cases we have discussed. For first case, this is the braking torque. For second case, again anti-clockwise and anti-clockwise, there are two formulas. जर तुम्ही स्वतःहून जर असे लिहिले एखाद्या पेजवर आणि समराइज केलं तर ते तुम्हाला एक्झाम मध्ये आन्सर लक्षात ठेवायला सोपं जाणार. ओके, नाव we will check another case. So okay, so third case, when line of action of the tangential braking force passes through distance a above the fulcrum. Distance a above the fulcrum. Now previously, so this was the disk, this is ft, and this is the lever, and this is O point, and this one is the offset. Now here, in this case, this one is this is ft, and as per the condition mentioned, this F is acting through a line which is at a distance. So this is the case. लक्षात येतं अजय? रेवन्नाथ? हा, ओके. रेवन्नाथ, किरण, सौरभ?
हाँ यस सर.
Okay. So when the line of action, now third case, when line of action of the tangential braking force Ft passes through a distance a above the fulcrum. So this one is the fulcrum, this one is distance a. So this line passing through the fulcrum and line passing through this Ft, there is offset, but that offset is provided below the tangential force line. So here, now we are going to write the equation by considering equilibrium and taking movement about the fulcrum. So first, as usual, Rn into x minus p into L, p into L. Now this is A and this is EFT. So this will rotate in clockwise. So we can write this minus. So I will write in other way. This Rn into x minus p into L downward downward, this one is upward. So here it is plus, minus, and again this ft into a. So anti-clockwise as a positive and clockwise as negative is equal to 0. So Rn into x is equal to TL plus ft into a. So by putting value of this ft, we are going to write mu Rn. So for equilibrium, taking moment about the fulcrum O, they have written directly the second step and they have equated anti-clockwise movement and clockwise movement with each other. So this is next Rn into x minus ft into a is equal to pl. Okay. So value of this ft mu Rn, again take Rn as a common, x minus mu a bracket complete is equal to p into l. So this is value for Rn. This is value for Rn. Now here itself you can predict that what is change between the fulcrum below the tangential line and fulcrum above the tangential line. So this sign is changed. So whenever, so just I will draw here ft. So this one is distance. This is the formula. Now previously we have seen this is fulcrum and here eft. Here it is. हा फलक्रम वर होता, इथं फलक्रम खाली आहे. त्या केस मध्ये इथं काय होतं, pl x plus mu a, x plus mu a. So just how it is important, you can see only slight change they have given. फलक्रम जर वर असेल तर इथं प्लस साइन येते, फलक्रम खाली असेल तर इथं मायनस साइन. Okay. So again braking torque TB is equal to this mu Rn into R. So therefore TB is equal to mu PL into R upon x minus mu V. Then when line of action of the tangential braking force Ft passes through a distance a above the fulcrum, same case, only anti-clockwise rotation. So for this, what will be the normal reaction? This PL x and there will be mu a. This we have seen. For this, here there will be plus sign. only this much change. Now we will check that also. Okay. For the equilibrium, again they have written like this. So normally we can write like this: Rn into x minus P into L minus Ft into A is equal to 0. Okay. Then this is next. Okay. So what is sign? Here plus sign is there, and braking torque is equal to this. Okay. To summarize three cases, just we will revise all the three cases. Okay. So first case, just I will refer here. You should remember these formulas. Case 1. In the case 1, what we have seen. So in short, this is EFT, and here I will write fulcrum as EF, and just we will make a simplified diagram. This is rotating in clockwise direction. In that case, what is value of braking torque? Or simply we know this TB is equal to mu Rn. You should remember only this Rn. So just we will write only this value regarding the Rn. So in this case, Rn is equal to, एक लक्षात ठेवा कुठलं. So Rn is equal to P into L upon X. Again, the same situation, only this rotation is changed. So this one is clockwise, anti-clockwise. No change in the Rn that we have seen. So P into L upon X. Then second case, what we have seen, when line of action of tangential braking force, this we have seen. This is F, and this one is rotating in clockwise. This is A. Here Rn is equal to PL upon X plus mu A. Okay. Now, if this is clockwise, then this is the equation. If it is anti-clockwise, then PL upon X minus mu a. ओके, हे लक्षात ठेवा, असं लक्षात ठेवायचं. देन थर्ड केस, here in the third case, this is lever, this is the lever, and this is ft, where it is ft, this is o, o, and line of tangential braking force is above the fulcrum. In that case, this Rn is equal to PL upon x minus mu a, and for which this is for clockwise, and Rn is equal to PL x plus mu a. This is for anti-clockwise. काय फरक आहे? All equations are same, only change with respect to the direction of this rotating wheel or the drum. So like this, every student should make their summary sheet with respect to each chapter to have correct answers, or to give the correct answer, and they should have practice with respect to that summary. Okay, so next part I will cover, we will learn in the next lecture, today's next lecture.